right. 4, 10, 19. So objective is we need to talk about inverse variation. And as an example, x times y equals 24 is an inverse variation. Because if you looked at the points from our sheet, okay, if you looked at our points from our sheet, we just got done doing this, we had points, see, we have there's a still, no, okay, well, I'll just show real quick. If we looked at our points like went from 124, 2, 12, 3, 8, 4, 6. As one number got small, the other got big. This number got a little bit bigger, this one got smaller. This number got a little bit bigger, this number got smaller. So as one goes up, the other goes down. In fact, you saw that on your graph. As one value gets bigger, the other gets smaller, correct? That's inverse variation, okay? So, inverse variation is going to have either x, y equals some number, and the book likes to call it k, and the k is called the constant of variation, okay? So k is called the constant of variation, okay? And of course, in our example, k was 24, correct? So the constant variation, so you've got xy equals a number, just some number, and they like to call that number the constant variation. In our example, the constant of variation was 24. Some books do. Yeah, but C is used for, well, C is used for a lot of things, and that's why they normally don't, but some books have. Great question, really good question, okay? Or we could write this as y equals k over x, okay? Now, that's inverse variation. My bad, I put these in the wrong place. That's okay, we can do it. Now, direct variation is this. Direct variation is as one gets big, the other gets big. Right? As one gets big, the other gets big. Easy example of that graphically is this. Okay? This is an example of direct variation. As x gets bigger, so does y. It's directly proportional. Okay? So it's in the form of y equals some mx plus 0. Make sure you put plus 0, okay? So to be a direct variation, it has to be a straight line. It's got to be straight. So to be a direct variation, I've got these backwards. Okay, if I could start over again, but I get so excited about talking about this one. M is the slope, but they, again, will call that the constant of variation, okay? So the book is going to call it like this, y equals kx, but k is just the slope. K is just the slope. Again, they're going to let k be the constant variation, but k is just the slope. So to be a inverse variation, two things, straight, and it must go through the origin, and through the origin, okay? Has to, okay? So, example 1. Yeah, this is definitely inverse variation because you've got x times y equals some number. This is an inverse variation. It fits the formula perfectly, okay? xy equals a number. The constant variation is negative 12, so yes, this one is my inverse variation. Okay? X times y equals a number. And it would have one of those weird looking hyperbola graphs, okay? X plus y equals 0. It is not an inverse variation. But if I solve for y and bring over the x, it would be y equals a negative x plus 0. Negative 1 over 1. This one would be a straight line. Has a slope of negative 1. And it goes through 0. So this one's going to be our direct variation. Now example 3 is a little weird, but I think example 3 fits that model where y has already been solved for. If I wanted to rewrite example 3, I could have brought the x up and multiplied by x. and I could have said 5 is equal to x times y. So a number times a number equals 5, right? In all the combinations. That's definitely an inverse variation. Because I have a number times number equals some constant, which is the 5, right? And it would look like a hyperbola. You have all the combinations of 5, right? 1 and 5, 5 and 1, and all the fraction decimals in between, okay? Now, example 5. Maybe. Let me go ahead and try and solve it first. If I bring up the 4x, just multiply by the 4x. Oh, I'm ahead of myself, sorry. I'm ahead of myself. 4 minus 4. We might not have homework today. Doggone it.
Darn.
So, but let me finish the notes and then just life goes on, huh? So we'll have an x minus 4 equals a 2y. I'm rushing because of homework, and I'm going to stop rushing, and we're just not going to have homework, okay? Yeah. Thumbs up on that one?
Yeah.
Divide by 2, divide by 2. I get a 1/2 x minus 2 equals y, right?
But it can't be both because it's not going through the origin.
Give that girl a gold star. Nice. Perfect. It is a straight line. It is a straight line, but it starts at -2, so it's neither. It's not direct, and it's not inverse. It's neither. Good job, Daisy.
It's neither because it starts at -2.
Yes, exactly. It has to go through the origin, okay? Now, example 5. Let me see if I can fix example 5. I'll rewrite it as y over 4x equals 12, okay? So it's just easier to see. I just rewrote it. Instead of typing form, it's more in like handwritten form, okay? So if I wanted to solve for x, I would probably multiply by 4x, right? Multiply by 4x, okay? And I'd get a y equals a 48x. Well, what do you know about that equation? What kind of line would that be?
That would be
Direct.
It'd be direct, right? It starts at 0 and the slope would be up 48 over 1, right? This is definitely direct. Okay. It has to go through the origin. If it doesn't go through the origin, it doesn't work, okay? Are you guys ready to turn the page? Pretty easy so far?
the first one on the page is a square root.
Yeah, I think that this is a parabola. I think it's really, looks like perfect squares, right? Looks like it might be a y equals possibly a 2 to the 4 squared, 6 squared. It might just be an x squared equation. I heard somebody say parabola, right? Who said parabola? Nicely said.
Oh, no.
Yeah,
I just said it was a
x squared. So this one's neither, right? This is really a quadratic. That's a quadratic for sure, okay? But what about example 7?
Neither.
Well, let's check it out. What's 1 times 5?
I'm kidding. It's
What's 5 times 1? Okay, 8 times 0.625. I'm going to have a calculator. 8 times.
I'm guessing 5.
I think it's probably a pretty good guess. 20 times 0.25. So it seems like it's x times y is always going to equal 5. I think that's what we got going on here, is x times y is always going to equal 5. So this one's going to be the inverse variation. Variation. Okay, last but not least, okay? Example 8. X varies with y. So I got an x, y equals. Well, equals some k. We don't know what the k is yet. X varies inversely with y. X, y equals some k. All right, we don't know what k is, but let's figure it out. Well, when x is 2 and y is -3, then what's k? Everybody agree? K is -6? This isn't that hard, is it? So I know that k is -6. So my equation is going to be x, y equals -6. Okay, here's my equation. Now, if I want to use my equation, if x are 12, what's y?
-1/2.
Perfect. So now let's use my equation. Let's plug this one in. Put 12 right in here. Let's go. All right, 12 times my y equals negative 6. Y is equal to negative 1/2. Good job. So tomorrow we'll pick up from here and